today's lesson, we are going to begin with the first lesson in Unit 1, which is called the set of rational numbers. What is the set of rational numbers and what are the elements inside of this set? Before we go and answer those questions, let's first remember some of sets of numbers that we have studied previously. We studied before the set of counting numbers, and if I ask you now to start counting the pens in front of you, you will start from 1, 2, 3, and so on. So set of counting numbers is the set of the numbers 1, 2, 3, 4, and so on. What was the meaning of those dots? Does anyone remember? Those dots means that this set is an infinite set. What's an infinite set? Infinite set is a set that has no end. So simply, I cannot say what is the largest number in the counting numbers, but I'm sure that 1 is my smallest counting number. The second set that we have studied before was the set of natural numbers n. And this set consists of the set of counting numbers and I add to it a 0. This set is also an infinite set, meaning that I don't know what is the greatest natural number, but I'm sure that 0 is my smallest natural number. The other set that we studied before was the set of integer set. Set of integers consists of 0, positive whole numbers, and negative whole numbers. And please remember, 0 was neither positive nor negative. What is the meaning that 0 is neither positive nor negative? It's not a negative number and it's not a positive number. By having a look at this set, you will find that this set is infinite. I cannot say exactly what is my smallest integer. And also, I can't say what's my greatest integer. The set of integers is infinite from both directions. I don't know what is the smallest integer or the greatest integer. But I know that 1 is my smallest positive integer and negative 1 is my greatest negative integer. If I want to represent those three sets inside of Venn diagram, so first I will have the set of counting numbers, which is a subset of the set of natural numbers, and both of them are subsets of the set of integers. By looking on the elements found in those three sets, you will find that those elements are all in the form of whole numbers. What about if I want a fraction or a decimal? That's what we are going to learn in the set of rational numbers. We would like to know that the set of rational numbers is the set Q. I denote to it by the letter Q. So Q is the set of rational numbers. What is a rational number? To say that a number is rational, I have three conditions. A rational number is a number that can be expressed in the form of A over B. So my first condition is this number can be written in the form of fraction. My second condition is that A and B are integers, meaning that my numerator and my denominator must be whole numbers, either positive whole number or negative whole number. And the third condition is that B is not equal to 0, because simply I cannot say I am going to divide 2 pens on 0 number of students. This will give me a math error. Why? Because I cannot divide or distribute on 0. We studied before in primary 5 that we have two ways to represent a set, either by a listing method or by a descriptive method. And here is the descriptive method for the rational numbers. The rational number Q is set of x, where x equal A over B and A belongs to Z and B belongs to Z and B is not equal to 0. Let's go for question number 1 and see how we are going to solve it. Before we start solving question 1, let's first remember that a rational number must be written in the form of a over b, and a should belong to integers. A is my numerator. My denominator, which is b, should also belong to integers. And my denominator b should not be equal to 0. And those are the 3 conditions that I have to say that this number is a rational number. So let's begin now with number a. 7 over a is a rational number. Then a is not equal to. In this question, he already gave me the number in the form of a over b. And he told me that it's a rational number. In order to have a fraction, a rational number, the most important condition is that my denominator, which here is a, should not be equal to 0. So a should not be equal to 0. Let's go for number b. 3 over x minus 2 is a rational number. Then x is not equal to. Already again, he gave me the form of a rational number, which is in the form of a over b. And he told me that this fraction is a rational number. In order to have this fraction as a rational number, the most important condition is that my denominator is not equal to 0. So here, I want to say that x minus 2, which is my denominator, is not equal to 0. I am going to answer it as a normal equation by moving the minus 2 to the other side with plus 2. So now I will have x is not equal to 2. So in order for this fraction to be a rational number, x should not be equal to 2. Let's go for number c. X plus 7 over x minus 3 is a rational number. Then x is not equal to, and again, I was given the fraction form in the form of a over b. I have here x in my numerator and also in my denominator. But for a fraction to be a rational number, the most important condition is that my denominator should not be equal to 0. So I am going to say that x minus 3 is not equal to 0. I'll solve it as a normal equation by moving the minus 3 to the other side with addition. As a result, I will have x is not equal to 3. So x is not equal to 3 in order for x plus 7 over x minus 3 to be a rational number. Let's go now for number d. In number d, 2 over 3x is a rational number. Then x is not equal to. In this case, already he gave me the fraction, and he's telling me that this fraction is a rational number. And we said that the most important condition for a fraction to be a rational number, that my denominator, which is in this case is 3x, should not be equal to 0. This is 3 times x. So I am going to move the 3 to the other side with the inverse, which is division. So here now, x should not be equal to 0 divided by 3. So x should not be equal to 0. X should not be equal to 0 in order to have this fraction as a rational number. The coming 2 questions are a little bit different. So let's concentrate. If the rational number x minus 2 over 5 equals 0, then x is equal to what? First of all, to have a fraction equals 0, this means that my numerator is equal to 0. So here, I'm going to solve x minus 2 is equal to 0. And this is a normal equation. I will move minus 2 to the other side with the inverse. So now here x is equal to 2. So here x is equals to 2 as well. Let's go for number f. The rational number x minus 3 over x equals 0. To have a rational number equals 0, this means that my numerator is equal to 0. So I want to say here that x minus 3 is equal to 0. I am going to move the minus 3 to the other side. So x is equals to 3. So in order to have this fraction as a rational number, x should be equal to 3. I want you to pause your videos and write this question in your classwork copybook and write today's date on it. We can say that all decimal numbers are rational numbers. Is this statement true? Let's go and see. In question number 2, state which of the following is a rational number. Is those numbers irrational numbers or no? First of all, we should remember that a rational number must be written in the form of a over b. And a rational number, the numerator should belongs to z and the denominator should belongs to z. And my denominator should not be equal to 0. And here are the 3 conditions for a rational number. Let's go and start solving number A. Number A, 7.5, and this is the decimal number. Can I convert the decimal number to fraction? Yes. We studied before in primary 4 that I can count how many decimal places do I have, and in this example I have 1 decimal place. So my denominator is going to be 10. And then I am going to write the number as it is without the decimal. So 75 over 10. 75 over 10 is in the form of a over b. 75 belongs to integers, 10 belongs to integers, and my denominator is not equal to 0. So yes, 7.5 is a rational number. And that's why we can say that decimals are rational numbers. Let's go for number B. Negative 2.3. Negative 2.3 is a decimal. To convert a decimal to a fraction, I must count first how many decimal places do I have, and in this example it's 1. So my denominator is 10. And then I am going to write negative 23 as it is without the decimal. I have reached the form of a over b. Negative 23 belongs to integers, 10 belongs to integers, and my denominator is not equal to 0. So yes, this decimal, which is negative 2.3, is a rational number. Let's go for number C. 3 minus 3 over 4. This is already in the form of a fraction. What is 3 minus 3? 3 minus 3 is 0. 0 divided by 4 is equals to 0. But let's look at this form. This is in the form of a over b. My numerator, which is 0, is an integer. And my denominator is an integer as well. And also my denominator is not equal to 0. So yes, 3 minus 3 over 4 is a rational number. Let's go for number D. 4 squared. We know that 4 squared is equals to 16. 16 is an integer. Can I write this integer in the form of a rational number or in the form of a over b? Yes, I know that 16 is equals to 16 over 1. 16 belongs to integers, 1 belongs to integers, and my denominator is not equal to 0. So we can say that 4 squared, which is going to be an integer, this is a rational number. Since I was able to write it in the form of a over b, and my denominator is not equal to 0, and both a and b are integers. Let's go for number E. Number E, it's a mixed number. Do you remember how can we convert mixed number to a fraction form or to an improper fraction? We simply used to keep our denominator as it is. Multiply the denominator by the whole number. So 3 times 4 is 12. And then I am going to add to it the 1. So it is 13. 13 over 4 is in the form of a over b. My numerator 13 belongs to integers, and my denominator 4 belongs to integers as well. And my denominator is not equal to 0. So yes, 1 over 4 is a rational number. Let's go for number F. And please pay attention here with me. 4 over 5 minus 5, is this a rational number or no? First, my numerator is 4. What about my denominator? 5 minus 5 is 0. And keep in mind that we said that my denominator should not be equal to 0. So, 4 over 5 minus 5 is not rational. Let's go for number G. 0.72. It's a decimal. How many decimal places do I have? I have 2 decimal places. So my denominator is going to be over 100. And I'm going to write the whole number as it is without the decimal. 72 over 100. My numerator 72 is an integer. My denominator 100 is an integer, and my denominator is not equal to 0. So yes, 0.72 is a rational number. I would like you to pause your video and write question number 2 in your classwork copybooks. What about the percentage? Are all percents rational numbers? Let's go and see if percents are rational numbers. First, I would like you to know that percent means part of 100. Meaning that I am taking only a small part of the 100. So in question number 3 here, state which of the following is a rational number. Let's see if I can write the percentage in a form of a over b or no. We said that any percent means that I am taking part of the 100. I am taking a number from the 100. 15% means that I am taking only 15 out of the 100. I have reached the form of a over b. And my numerator belongs to integers. And my denominator also belongs to integers. And my denominator is not equal to 0. So yes, I can write a percentage in the form of a over b. So the percentage is a rational number. Number B, 7.5%. We said that a percent means a part of the 100. So I am taking only part of the 100. But keep in mind that here it's 7.5. I must get rid of these decimal places. How many decimal places do I have? I have 1 decimal place. Since I have 1 decimal place, I must add here a 0. And then I am going to write the 75 as it is without the decimal and without the percentage. I have reached the form of a over b, and a belongs to z and b belongs to z, and my denominator is not equal to 0. So 7.5% is a rational number. Let's go now for number C. 102%. We said that percent means I am taking a part of 100, right? How many part of hundreds I am taking? I am taking 102. I have reached at the end the form of a over b, My numerator belongs to z, my denominator belongs to z, and my denominator is not equal to 0. So yes, and 102% is a rational number. Copy-paste this question in your classwork copybook. All integers are rational numbers. Is this statement true? Let's go and see if this statement is true or not. If I told you, for example, I have an integer 3. Is this 3 a rational number? Yes. Why? Because I can write it 3 over 1. Any integer can be written in a fraction form by putting it over 1. So 3 now is written in the form of a over b. The numerator, which is 3, belongs to integers, and my denominator, which is 1, belongs to integers. And my denominator is not equal to 0. So yes, I can write the integer in the form of a rational number. What about, for example, if I told you 1? Can I write 1 in the form of a rational number? Yes, because simply I know that 1 is equals to 5 over 5 is equals to negative 4 over negative 4 is equals to 10 over 10. 1 is equals to any numerator over the same denominator. And this is always going to give me 1. So yes, again, another example of integer, and I can write it in the form of a rational number. And what about 0? Can I write 0 in the form of a rational number? Yes, sure. Simply, 0 is equals to 0 over any denominator. If I divided 0 by any number, I will always get 0. So, 0 over any number is equal to 0. As a result, I have reached that this integer, I can write it in the form of a over b. Let's go now and see this remark. Each integer is a rational number. But keep in mind that not each rational number is an integer. Let's go and see question number 4. State which of the following is an integer. The first one is 2 over 5. This is a mixed number, so I must change it first to an improper fraction. How can I change it to an improper fraction? First, I'm going to leave my denominator as it is. And then I am going to multiply 5 times 3, which is 15. And I'm going to add 2, so my new numerator is 17. 17 over 5, is this a rational number? Yes, 17 over 5 is a rational number. But is 17 over 5 an integer? No, 17 over 5 is not integer. Why is 17 over 5 not an integer? Because simply 17 cannot be divided by 5. So here's an example of a rational number and it's not an integer. Let's go for the other rational number, negative 35 over 7. Negative 35 over 7, if I write it over my calculator, I will find the answer of negative 5. Because negative 35 can be divided by 7. 7 times negative 5 is equals to negative 35. So here is an example of a rational number, and it's in the same time an integer. Let's go for number C. 7 over 7. 7 over 7 is a rational number, right? And I know that 7 over 7 is equals to 1. We said that when I have my numerator the same as my denominator, this is equals to 1. And 1 is an integer. Let's go for number D. Number D is 0 over 4. We said that when I have 0 as my numerator over any number, this is always going to be equal to 0. And yes, 0 is an integer. Let's go for the last one, which is 4 over 8. 4 over 8, both the numerator and the denominator is divisible by 4. So if you write it even on your calculator, you will find that 4 over 8 is equals to half. And half, of course, is equals to 0.5. So the question is this rational number an integer? No, it is not an integer. So let's have a look here. In this question, he gives me rational numbers and want to see those rational numbers are integers or not. We found that some of them are integers and some of them are not integers. Some of them are going to give me whole numbers at the end and the others are going to give me fractions. So, again, we are coming to the main point here in this remark, which is not all rational numbers and integers, but all integers are rational numbers. By now we have finished part 1 in this lesson. We are going to continue the second part in the other lesson. Thank you, Prep 1, and have a nice day.